I've heard some people say peak, I've heard some people say RMS. I have not found the answer to that question that I'm looking for. Am I using all RMS values or all peak values?
Doesn't matter.
I heard the answer, yes. Okay, the answer is yes. This formula is either all RMS or all peak, but don't mix them. So what that means is if I put in a voltage that is the peak voltage of the power supply, I get the peak current of the circuit. If I put in a voltage that is the RMS value of the power supply, then I get the RMS value of the circuit. Which one is bigger, peak or RMS? Peak. And what is the factor between peak and RMS? Square root of 2. So, if they gave me RMS, and I wanted, for this one, and I wanted peak, I would bump this by square root of 2 before I plugged it in. Okay? If, on the other hand, they gave me peak and asked for peak, then I'm in good shape. I just do it. So, voltage given was 10 volt peak voltage, and the very next question is determine the peak current. So, for now, this equation is all in peak. And you could put that in here by, let's say, putting a little, I don't have quite room to put parentheses P to say that these are peak voltages. Okay? So what is the peak voltage? 10 volts. And what is the phase of the voltage on the power supply? 0. So that's the power supply written in C e to the I phi format. It's got a magnitude of 10 volts, where we've decided that magnitude means peak for now. And it's got a phase of 0. Therefore, the magnitude of the peak current is what? 10 volts over 160 ohms, which is how much? 0.0625 amps. It's volt over ohm is amp, just like it's always been. Okay? And the phase, don't just set phi equal to a number, there are a gazillion phases. The phase of the total current is equal to, this is e to the I0 divided by e to the minus I41. When you move this thing in the denominator up to the numerator, it becomes e to the I plus I41. So this is going to be 0 plus 41 degrees, which is 41 degrees. .065?
Yes.
Thank you. Okay? Yes. I'm going to get to that. Yes. Sorry, I couldn't hear the question. It is 0 minus 41. So, when you take the ratio of 2e to the I, you subtract the bottom one, but we have to subtract negative 41, and that turns into adding 41. Okay? Everybody good so far? Now, we seem to have answered part E having skipped by part D. What is the RMS total current?
1.065 over radical.
Yep. The RMS value of anything is smaller than the peak value, and it's smaller by square root of 2. So 0.0625 over square root of 2 is how much? .044. And currents are still in amps like they've always been. So what it means is that the current of this circuit is an oscillating function. It goes up and down and up and down and up and down with time. It goes from plus 0.0625 to minus 0.0625 because those are the peaks. And that means that it is a current with an RMS of 0.044 amps. Now the current does not peak at the same moment that the voltage of the power supply peaks. The current is not highest when the power supply voltage is highest. The reason is this circuit contains a capacitor. And a capacitor is which first, then the other. Fill that in with voltage and current. Current first, then voltage. Okay? So what this means is that the current is first before the voltage appears. Now, on a capacitor, if you say my capacitor is current and my voltage, that difference is 90 degrees. But this circuit, which is a combination of an R and a C, is capacitive. And so that means the current is only ahead of the voltage by 41 degrees instead of by 90 degrees. If it was a pure capacitor circuit, then the current is ahead by 90 degrees. However, it's not purely capacitive. There's also some resistor that wants current and voltage to be the same, so the current is only ahead by 41 degrees. That's the result so far. Yes? In any circuit, the phase of the current is basically opposite the phase of the voltage. Because I is V over Z, and so you will wind up subtracting the phase of the Z from the phase of the voltage. And so that's what produces the minus sign, because you subtract phase of the impedance to get phase of the current. And if you were a mathematician and you solved this equation the other way around, because you said, oh, look, let's say somebody gave you the voltage and the current and asked for the impedance, you bring the impedance over here, you bring the current over there, and it would still work mathematically. This is not just a one-way equation, this is an equation with full ability to do math in every direction. We just happen to be doing it more or less the same direction most of the time. Yeah? Okay, if I gave you a function that said cosine of omega t plus 50 degrees, and I just gave that to you, and I asked you to pick out pieces of that equation. Now let's say 20 volts times the cosine of omega t plus 15 degrees. You got that in your mind? If I asked you to take that equation and pick out the peak voltage, what would you say? 15 degrees is not a voltage. Yeah, 20 volts. I wouldn't then ask you, what happened to the cosine? Because I would say you took an expression that had all quantities in it, and you removed from that expression the quantity of interest. So if I gave you that same expression and I asked you what was the frequency, you would say, oh, first thing I'll do is, having seen that whole expression, I'll pull out the omega, then I'll set that equal to 2 pi f, and then I'll tell you the frequency. I wouldn't then say, well, what happened to t? Because what you did was you reached inside a full expression and you pulled out the piece of it that was meaningful to you. Okay? When I give you e I to the I 5, and I ask you, what's the phase? You plucked out phi because it is the phase. And so it's not that something happens to e to the I phi. E to the I phi is a full expression. The one piece of it is the phase. And so you plucked it from inside of the relation. Okay, other questions at this point? Now, this circuit is a series circuit. All circuit elements in series have the same current. So this I total is actually equal to the I through the resistor, and it's equal to the I through the capacitor, because all circuit elements in series have identically the same current. Okay? So the next thing I want to solve for is what's the voltage on the resistor?